My name is Ellie.
I'm Ivan.
And we're here to talk to you about wave properties. We're going to tell you about transverse waves and longitudinal waves, and
constructive and deconstructive
interference. First, we have transverse waves. Transverse waves oscillate perpendicular to the direction of travel. In this drawing, the wave is traveling left to right. The amplitude is the height of the wave, or the distance between the crest or trough and the equilibrium line. The crests are the highest point of the wave on top of each oscillation. The troughs are the lowest point of the wave on the bottom of each oscillation. One wavelength is the distance it takes for the wave to repeat itself again. Here we measure it from the place where the wave crosses the equilibrium line going up to where it crosses the line going up again. A wavelength is shown by this sign.
Next we have longitudinal waves. These waves move parallel to the direction of travel. These are also called compression waves. The parts where the coils are more spread out are called rarefaction areas. The parts where the coils are more dense are called compression areas. These waves are formed by compressing the slinky and releasing. When I release the wave, parts of the slinky are darker than the others. These are the compression points.
Two things can happen when two waves come into contact. The first is constructive interference. When two waves come into contact, their amplitudes are added together to create a wave with a larger amplitude. This first example is of two positive waves coming into contact to create an amplitude that is the sum of the amplitudes of the original waves. If the amplitude of the first waves were 1 and 1, the resulting amplitude would be 2. If they were 3 and 5, the resulting amplitude would be 8.
The second example of constructive interference is of two negative amplitudes coming together to form a larger negative amplitude. If the two original waves both had a -2 amplitude, the resulting amplitude would be -4, and if they were -3 and -4, the resulting would be -7.
The second possibility when two waves come in contact is destructive interference. This is when the two original waves have opposite amplitudes that result in a zero amplitude wave, or a still line. Here, the first amplitude is 1 and the second is -1. When they meet, they cancel each other out and result in a still line, or an amplitude of 0.